We're going to be talking about rational exponents in section 6E. And so recall the laws of exponents. We got power man here. And power man says that if we have a power to a power, we're going to multiply exponents. So here's an example of a power to a power, and we're going to multiply m times n. He says that if you're multiplying two expressions, you're going to add their exponents. So here's an example of multiplication with the same base, and it's going to result in adding the m plus n. If we got division like we do right here, then we're going to combine them. We're going to move it whichever's the heavier ones, whichever's bigger, and we're going to take it and subtract the other. If we have this ab to the m power, then we can take, if this is multiplied, we can take each factor and raise it separately to the mth power. Same thing with a quotient. We can raise the numerator to the m power and the denominator to the m power. So a quick review of those. So all these laws are going to apply to rational exponents. And a rational number is a number that can be expressed as a fraction. Should have the word a right there as a fraction. All right, so some examples. I have 8 to the 1/2 times 8 to the 2/3. I'm multiplying, so I'm going to need to, according to power man up here, multiplying, so I'm going to add my exponents. So, but when I add them, I have 1/2 plus 2/3. I need a common denominator, so that's going to be 6. So that's going to be 3/6 plus 2/3. When I change it to 6, is going to be 4/6. So when I add that, I get a to the 7/6 power. If I have a power to a power, I'm going to multiply exponents. So I'm going to have x to the 2/3 times 3/4. So my 3's will cancel. And so am I this. I'm going to get x to the 1/2. So this is really going to be 6 over 12. 3 times 2 is 6. That's a big dot right there. 2 times 3 is 6, and 3 times 4 is 12, and 6 over 12 reduces to 1/2. And then this last one, I need a common denominator. I'm going to have to be doing some subtraction. So let's just do that. I'm going to change them both to tenths. So 1/5 then is going to be equal to 2/10 over n to the 7/10. So when I do this, I can see that the 7/10 is the heavier one. So everything's going to move this direction, and that's going to leave me with a 1 in the numerator, and then n to the 7/20 minus, that's 7/10 minus 2/10. So that's going to be 1 over n to the 5/10, which reduces to 1/2. So 1 over n to the 1/2. All right, so take a minute and try these. Don't wait to the end. So while these are fresh on your mind, give these a try. All right, so for example 2, we're just going to multiply. And again, you see we have these rational exponents in our multiplication. So we're going to distribute just like we would with numbers and plain variables. So when I multiply, I'm going to multiply z to the 2/3 times z to the 1/3 minus, and then go back and distribute again, z to the 2/3 times z to the 5th. So when I multiply, I'm going to have to add my exponents. So 2/3 plus 1/3 is 3/3. And of course, 3/3 reduces to a 1. And then minus 2/3 times 5 over 1 is going to multiply. There I was multiplying. So when I multiply, I need to, again, add my exponents. So what we might do is we might come up here and think, so I've got 2/3, and 5 is going to be equal to 15/3. So that is going to give me z to the 17/3 right there. So 2 plus 15 gives me 17/3. And of course, you don't want to write your z to the 1. You want to erase that. I can't do it, but you could. All right, so B, I'm going to have to double distribute or FOIL it, however you want to say it. And if I write it all out, I'm going to have x to the 1/3 times x to the 1/3. And then the two outer ones, which is going to be 2 times x to the 1/3. The inner one, negative 5 x to the 1/3. And the negative 5 times positive 2 is negative 10. So when I'm multiplying, I'm going to add my exponents. So that gives me x to the 2/3. I'm going to combine these. These are like terms. They both are x to the 1/3. So I can add the positive 2 and the negative 5 and get negative 3 x to the 1/3. So remember, Power Man says that when you're adding, you do nothing with those exponents. So that's why it stays the same there on the exponent. And then minus 10. And then that's going to be my answer. So you give a try at C. And this will be the end of the video, so we'll pick back up on video 2.